Find the limit as x approaches 2 of x squared plus x minus 6 over x minus 2. Like in the previous example, we can use our quotient property of limits. Just like in the previous example, the top is a polynomial and so is the bottom, so that means we can just substitute 2 in for x and we can evaluate the limit that way. However, whenever we substitute 2 into the denominator, we get 2 minus 2, which is 0. We can have any value for the top, that doesn't matter. However, for the bottom, the only value that we cannot have in the denominator is 0. So the function is not defined at 2. Remember that we did direct substitution here because of the type of function this was. However, that doesn't mean that the limit does not exist. Remember that the limit isn't concerned with what's happening at 2. We care about what's happening around 2. So if you substitute the x value and you get 0 in the denominator, that doesn't mean the limit does not exist. That means we need to approach computing the limit a different way. One of the things that we can do in order to compute a limit that's undefined whenever we substitute the x value is factor. We have the following for the function, so now let's go ahead and factor the top and bottom if possible. We can factor the numerator as x plus 3 times x minus 2. And the bottom doesn't factor, so we just leave it as x minus 2. Notice that we have a matching factor on top and on bottom. So we have x minus 2 over x minus 2, and because these are the same, they reduce to 1. So that means that we can go ahead and cancel out the factors of x minus 2, and we are left with x plus 3. So now let's look at the limit of the function again. We originally have the limit as x approaches 2 of this expression, but now we can replace this expression with x plus 3. Now x plus 3 is a polynomial, so that means in order to compute this limit, we can just substitute 2 for x. And we have 2 plus 3, which equals 5. So the limit of the function as x approaches 2 is 5.